Hey guys, today we're going to talk about acceleration. So acceleration by definition is the rate of change of velocity. Since velocity is a vector quantity, it has a number and direction, acceleration is also a vector quantity. So it must include a directional component. Whether it's speeding up or slowing down, or positive or negative, or left or right, it has to have some sort of direction included. That means that the effect of acceleration depends upon the original motion of the object. On the next slide, we're going to look at that a little bit more in depth. Acceleration can be trick questions. The goal is that they won't be, but you do have to pay attention. Acceleration can occur in two ways. The first way is changing the speed or velocity of an object. If you go from 20 meters per second to 25 meters per second, you've undergone acceleration. But you can also change direction. If you are traveling 20 meters per second north and then go around a curve and are traveling 20 meters per second east, you are still accelerating because that directional component is changing. Okay? So on this graph, what I'm going to do is give an example of acceleration or motion of this object. So we have a little car up here, and if he starts from stationary and moves with a positive acceleration, we are speeding up in the positive direction. Okay? If we are traveling in the negative direction, so we are stationary and then we have a negative acceleration, we are speeding up, but now we are going in the negative direction. Now things are going to get a little bit tricky. I do have to clear the screen because of the arrows. I don't want to get the arrows confusing. So please make sure you have these written down in this table in your notes. Speeding up positive, speeding up negative. I'm going to fill them in a little bit later, but as we go, I'm going to erase a bunch of times. Okay? So now we have positive motion. So I'm going to draw an arrow for this car, just indicating the motion that we're undergoing. So if we are moving in the positive direction, we are going this way on the number line. And then if we have a positive acceleration, the arrow goes in the same direction. So here we are going to be speeding up and we're going to be going in the positive direction. Now, if we look at it in the opposite way, this arrow is going to go away. If we have positive motion, this yellow arrow stays, but now we have a negative acceleration. That means we are accelerating in this direction. Notice these two arrows. They go in the opposite direction, so they actually cancel each other out a little bit. So here I'm going to write we are slowing down because those arrows are in different directions, but we are still moving in the positive direction. This would be the example of like coming up on a stop sign and applying your brakes. You're still moving forward, you're just moving forward at a slower rate. Now I'm going to do the negative motion. So if our car is in reverse and we are moving in this direction, I'm going to add a yellow arrow for a positive acceleration. Our acceleration would be going this way. So technically, since those arrows are in different directions, here we are going to be slowing down, but we are moving in the negative direction. Now this yellow arrow is no longer, we're going to ignore him. So we're moving the negative direction, and we have a negative acceleration. Now, since these arrows are going in the same direction, we are speeding up in the negative direction. So this example would be starting from rest, pulling away from a stop sign. This example would be starting from rest, but reversing down your driveway. This example would be you're on the highway and you want to pass a car, so you speed up. This example is you're on the highway, but you want to merge so you can get off an exit, so you have to slow down. This example, you are backing up, but you are maybe backing into a space, so you have to apply the brakes so you don't back up too quickly. This one, you are backing up out of a spot, but you are applying the acceleration because there's no one behind you. So notice it matters. Positive acceleration and positive motion means you're speeding up. Negative acceleration and positive motion means you're slowing down. If they are the same, you add them. If they are different, you subtract them. So here's our acceleration equation. The change in velocity over a time interval. So we can break that down a little bit further, and change in velocity is the final velocity minus the initial velocity and the change in time. Now notice direction does matter. So your acceleration might be 0 meters per second, but you're changing left to right, or you're changing north to south. That's okay. But we are using this basic equation of Vf minus Vi over change in t, and we are going to practice with this equation in class. So acceleration time graphs. These add on to the position time graphs and the velocity time graphs we've already worked on in class. So if we have this position time graph that is a positive constant value for a slope, this would be our velocity time graph, a positive constant value. Our acceleration time graph is the slope of this line. In my class personally, all of these lines are going to be either horizontal or a slanted linear line. So that means everything here will be some sort of horizontal line. Since the slope of this line right now is 0, we're going to draw our acceleration time graph at the 0 mark. Okay, now I'm going to draw another example that's going to look a little bit different. For this example, we are going to have a curved graph. Okay, so in class I talked about the handy dandy slope-o-meter, and you take your pen and you hold it at the graph at a certain point. So if you hold your pen here, it creates a horizontal line. So that's a slope of 0. If you hold your pen here, it creates a slightly positive slope. If you hold your pen here, it creates a slightly higher positive slope and a higher positive slope. So this creates a positive, constantly increasing value. Okay, so that is a straight line. Now the slope of this line is a positive constant number. So our acceleration is going to be here. Okay, so remember, I'm going to make some notes on this slide, and I'm going to color code them. If this slide is a straight line, this one is a horizontal line, and this one is horizontal at 0. If this line is curved, this one is a straight line, and this one is horizontal anywhere. So the red one, straight position time, makes a horizontal velocity time, makes a horizontal at 0 acceleration. Curved position time makes a straight velocity time, which makes a horizontal acceleration. So there is a constant relationship. Now I'm going to do a couple examples on the next slide as a quick introduction. We are going to talk about this a lot more in depth in class because this tends to be one of the hardest concepts in this class. So here, I'm actually starting with my velocity time graphs. Okay? This velocity time graph is a horizontal line. The slope of this line has a value of 0, so I'm going to draw my acceleration time graph on the 0. Okay? To go up here to the position time graph, since this is a straight horizontal line, this needs to be a straight line. But is it in the positive quadrant or the negative quadrant? Since it's above the axis, our position time graph is going to be a straight line that is increasing. Okay, if we look at the second one, our velocity starts at 0 and becomes a bigger positive number. So if we use our handy dandy slope-o-meter, like I'm going to show you in class, we are going to start with a slope of 0, which means our pen is going to be horizontal, and we are going to go up to an increasingly positive number. The slope of this line is a positive constant number, so our acceleration is going to be a positive constant number. I'm going to skip number 3 because that's kind of similar to number 2. So number 4, we are starting with a high positive value for velocity, and it's going to go to a 0 value for velocity. So using our slope-o-meter, we want to lay our pen down so we have a positive slope when our pen lays on the paper. So our slope is actually going to do this. A high positive, which goes less and less and less and less and becomes a slope of 0. Now the slope of this line is a constant value, but it happens to be negative. So down here, I'm going to draw an acceleration line in the negative quadrant of the acceleration time graph. Okay, so this is something we're going to be working on a lot in class. I just wanted to give you a quick review of the position time, velocity time, and now how they relate to the acceleration time. Remember, the slope of this graph gives you this graph, and the slope of this graph gives you this graph. So it is a constant change. It is the same relationship both times. All right, I'll see you tomorrow so we can practice with this.